Hello, my dear friends. How are you all? I hope you all are good and fantastic. So, friends, you are very welcome in our lecture number 2. So, I hope you will enjoy this lecture. Okay, friends. So, friends, without wasting the time, let's start. Yes, so today we will discuss about revisiting irrational number. Okay, so this is again a very important topic. Okay, so you have to be listen very carefully. Okay, yes. So before starting our topic, let's know about irrational number. Okay, so friends, in starting we already learned about the irrational number. Here we will see a brief description about the irrational number. Okay, so yes, so what is irrational number? Any number that cannot be expressed. Any number that cannot be expressed in the form of P upon Q. That cannot be expressed in the form of P upon Q. Okay, where P and Q are integer, and Q is not equals to 0. So what is irrational number? Those numbers which cannot be expressed in the form of P upon Q, where P and Q are integers and Q is not equals to 0. Okay, so I hope you get this point. And the another definition is that if a number which is non-terminating, which is non-terminating and non-repeating and non-repeating. Okay, so non-terminating and non-repeating numbers are also called irrational numbers. For example, let's suppose we have a number like 2.123491256 dot infinity. Okay, so now here this is a number of non-terminating. Okay, and also non-repeating means there is no repetition after the decimals. So that type of number are called irrational number. I hope you get this point. What is irrational number? Irrational number are those numbers which cannot be expressed in the form of P upon Q and which are non-terminating and non-repeating numbers. Okay, so I hope you get this point. Another examples are under root 2, under root 11, etc. Okay, so now let's move on. Yes, now here we discuss about the properties of irrational number. Properties of irrational number. Okay, so now what are the properties of irrational number? So friends, here is very important that our first property is that the negative of an irrational number is an irrational number. Okay, means if we have a irrational number and like if we have a number of root 2 and if we do the negative sign, then it is also called a irrational number. Okay, now next property is that the sum of rational and irrational number is an irrational number. Means sum of rational number and irrational number is always equal to irrational number. Okay, if we add one rational number and one irrational number, the result would be irrational number. Okay, yes. Next property is that the product of a non-zero rational numbers with an irrational number is always an irrational number. Here is again, you can see if we add or subtract, okay, if we add or subtract rational and irrational number, we get always irrational number. If we product or divide rational and irrational number, we always got a irrational number. Means again, rational multiplication or division of irrational number, we always got irrational number. Okay, yes. So now our last property is that if we have a prime number, let's suppose P is a prime number. Okay, if we take the under root of prime number, let's suppose under root of P. Listen to me very carefully. This is very important concept. If we under root P, okay, so this is also a irrational number. This is also a irrational number. Okay, so now here we can conclude that the under root of all the prime numbers are the irrational numbers. The under root of all the prime numbers are the irrational number. For example, under root of 3 is a prime number. This is a irrational number. Okay, irrational number. Okay, now same as under root 11, under root 5, all these numbers are the irrational numbers because they are the under root of prime numbers. Okay, so I hope you got this point. Okay, so now let's move on. Yes, now number theory means interesting results. We are doing a very important and interesting results. Yes. If a number P, which is a prime number, divides a square. Okay, if a number P divides a square, means a square can be divided by P, then A can also be divided by P, means P can divide also A. Let's suppose if we have a number 3 which is a prime number, it can divide 6 square, that is 36. Very easy. How many times? Yeah, 36 divided by 3 means 12 times. Okay, which implies that means 3 can also divide 6. Okay, means 6 can also, which is a square of 36 is a square of 6. Okay, and 6 can also be divided by 3. How many times? 2 times. Okay, so I hope you got this point. This theory is very important, which we will be used in the questions. Okay, So listen to me very carefully. If we have a number which is a prime number divides a square, then p can also divides a. Okay, I hope you got this point. Now take another example. If we have a number 7, okay, yeah, and it can divide 49, which is a square of 7. Okay, how many times? 1 times, 7 times. So 7 can also divide by 7. Okay, okay, I hope you got this point. Yes, now let's move on. Okay, so the sum or difference of a rational and irrational number is a irrational number, we already learned. Okay, the product and quotient of a non-zero rational and irrational number are irrational number. This statement also we have already learned. Okay, yes, this is again same properties of this. Under root p is irrational when p is a prime. For example, 7 is a prime number and under root 7 is irrational number. The above statement can be proved. Now, important thing is that in this statement, this is under root 7 is irrational. Okay, so this statement can be proved by the method of proof by contradiction. We will see. Okay, this method, this statement can be proved by proof of contradiction. Okay, so I hope you got this point. Yes, so now let's take an example. Yes, proof by contradiction. Okay, yes. So friends, in this method of contradiction, we have to check whether a statement is true or not. Okay, whether a statement is true or false. Yes. Now, first of all, we have to assume that the given statement is false. The given statement is what? False. So our first step is that we have to assume that the given statement is what? Yes, is what? Is false. Okay, my dear friend. Now, second step is that by doing some methods, we arrive at some result which contradicts our assumption. Okay, so we arrive at some result which contradicts our assumption. So we can say that the given statement is true. So we can say that what? The given statement is true. I hope, my dear friend, you understand these things. Let's suppose we have to prove under root 7 is irrational. We have to prove under root 7 is what? Irrational. So first of all, we have to assume that. First, our assumption is that in first step, assume under root 7 is rational. We are assuming that under root 7 is what? Rational. So my dear friends, we know that this is irrational, but we are assuming that under root 7 is rational. So now if it is a rational, so we can convert it into like under root 7 is equals to a upon b. We can write it in the form of a upon b because we are assuming that under root 7 is, yes, rational. And here is a and b are co-prime number. Co-prime number. Okay, my dear friends, I hope you get this point. Now we have a upon b is equals to under root 7. Squaring both the side. Okay. So we get a square is equals to 7b square. Okay. A square is equals to 7b square. Now hence 7 divides a. Why? Because from this case, a square 7 can divides a square, so 7 can also divides a by theorem first. Okay, we already learned. So there exists a c number, so hence 7 divides a. You have to follow just these steps and then you can solve easily. Okay, so then there exists a number such that then there exists a number c such that a is equals to 7c. Now we can also square both the sides, so we get 49c square. Okay, so in that case also, now we are comparing this and this. Okay, so we can write as 7b square is equals to 49c square. Okay, or 7 or and b square is equals to 7c square. Okay, we can cut by 7 times. From this statement we can conclude that 7 can divide 7 can divide b. Okay, okay, so now, so 7 is a common factor because common factor, it is coming in also a and b also. So 7 is a common factor for both a and b, so 7 is a common factor. 7 is a common factor. Okay, for both a and b. Okay, so it contradicts our assumption because a and b are we assume that a and b are co-prime number. Okay, and this contradicts our assumption, so we can say that our assumption is false, means under root 7 is rational is false. So therefore under root 7 is irrational. Okay, okay, so I hope you got this point. Yes. Now let's move on. Now again we have to solve some questions. Okay, so our first question is that prove that under root 5 is irrational. We have to prove that under root 5 is irrational. So first of all we have to do that. Let us assume that let under root 5 is rational. Okay, so we can say that is we can write also under root 5 is equals to x upon y. Okay, so y under root 5 is equals to x. Now squaring both the side. So it will become y square 5 is equals to x square. Okay. So or we can write it also 5y square is equals to x square. This is our equation number 1. Okay. So x square is divisible by 5. X means from this case we can conclude that x square can be divisible by 5. Okay. So now we can write x square can be divisible by 5. So x can also be divisible by 5. Okay. So let us say x is equals to 5k. We can say that. Okay. So for some value of k and substituting the value of x in equation 1. Now we are substituting this value of x in equation 1. It will become 5y square is equals to 25. 25 what? 25 k square. So now here it can be divided by 5 by how many times? 5 times. So y square is equals to 5k square. Now in that case also, now in that case 5 can also divide y, because from this case y square can be divisible by 5. So y also can be divided by 5. So here, so 5 is the common factor. So 5 is the common factors. 5 is the common factors. Okay. Common factors of x and y. And so that, so from this case our assumption of coprime and about under root 5 is irrational, and about under root 5 is irrational. Under root 5 is irrational is incorrect. Okay. So I hope you get this point. So hence under root 5 is, sorry, our assumption is what? Rational. Our assumption of coprime and about under root 5 is rational is incorrect. Hence under root 5 is irrational. So friends, you got this point. Okay. So now, so hence proof. Okay. So now let's move on. Yes. So again, we have to prove that 3 plus 2 under root 5 is irrational. 3 plus 2 under root 5 is irrational. So now, again, let us assume that, let us assume that 3 plus 2 under root 5 is rational. Okay, then we can find co-prime of x and y such that, okay, such that 3 plus 2 root 5, we can write it also 3 plus 2, 3 plus 2 root 5 is equals to x upon y. Okay, now we are rearranging them. Now it will become 2 under root 5 is equals to x upon y minus 3. X upon y minus 3. Okay, and under root 5 is equals to x upon y minus 3 into 1 upon 2. Okay, so now since x and y are integers, so this term is a rational number. Therefore, under root 5 is also a rational number, but this contradicts the facts that under root 5 is irrational. Okay, so from this case, this is rational. Okay, but we already proved that this is what? This is what? This is irrational. So irrational always is not equals to rational. So it contradicts that. Okay, so we can say that 3 plus 2 under root 5 is irrational. Okay, hence proof. Okay, so I hope you got this point. Now we will move on another question. Now let's find two irrational between 0.12 and 0.13. Okay, so very easy question. Yes. So now between two numbers 0.12 and 0.13, we can write it is also as 0.12 0 1 0 0 1 0 0 0 1 0 0 0 0 means 4 times 0 1 and so on. Okay, this is the first number, and our second number is that we can write as 0.121. Okay, 0 1, again 001, again 000 1, and 4 times 0 1 and so on. Okay, so the difference is this. Okay, 1. I hope you got this point. Now let's move on. Yes, so which of the following numbers are irrational? Okay, we have to tell that from these number what are these irrational or irrational. So first case are under root pi square. So we already know that pi is irrational. Pi is irrational. What is? Yes, pi is irrational. Okay, and so root of pi square is also a rational. Okay, yes. Now second case, cube root of 0.8. Cube root of 0.8. Okay, so we can write it as also 8 upon 10 raised to power 1 upon 3. Okay, So cube root of 8 is 2, and 10 raised to power 1 upon 3 we can write. And so now it will become 2 into 10 raised to power 2 upon 3 and 10. We can write it as also. So we can write as 10 raised to power 2 upon 3 divided by 5, because this goes to 5 times. Okay, so this is a irrational number. So this is a irrational number. This is what? Yeah, this is irrational. Okay, now yes, now we are talking about at this time. Okay, yes, and 0.00016. Okay, so how we can solve it? Yes, we can write it as also 0.2 raised to power 4 upon 10 raised to power whole raised to power 1 upon 4. Okay, so it can be written as 0.2 divided by 10 raised to power 1 by 4. Okay, which is a irrational. So now next question is cube root of -1. Okay, so now my dear friends, we have to tell that it is rational or irrational. So my dear friends, we know the value of cube root of -1 is -1. So this is what? This is rational. This is rational. Okay, now next is cube root of 0.001. Okay, so now if we solve this, we get cube root of 1 upon 1000, 1 upon 1000, and from this we get 1 upon 10, which is what? Which is rational. Okay, my dear friends, I hope you get this point. So now let's move on. Yes, let's prove that the following are irrational. Okay, so our first question is that 1 upon under root 2. Okay, so again let us assume that let 1 upon under root 2 is rational. Okay, now we can write it as also 1 upon under root 2 is equals to x upon y. Okay, now we here we can do the reciprocal of under root 1 upon under root 2, then it will become under root 2 is equals to y upon x. Okay, since x and y are integers, thus under root 2 is a rational number. But since x and y are integers, okay, and but this is x and y are integers, so these are rational. Okay, we can say, but this is irrational because under root of prime number is always irrational number. Okay, this is irrational. Now this is also contradicts our assumption. So 1 upon under root 2 is irrational. Okay, so I hope you get this point. So the next question is that 7 under root 5. 7 under root 5. So now let us assume that again. Let us assume again. Let us assume that 7 root 5 is rational. Okay. Okay. So now we can write it as also what? 7 root 5 is equals to x upon y. Of course, we can write it also. Now again, root 5 is equals to x upon y into 7, because 7 goes to here in the denominator. Now this term is rational and this is irrational. Okay, so this is irrational. Now again, this contradicts our assumption, and so we can write 7 under root 5 is equals to irrational. Wait a minute, is irrational. So friends, we can do it by another shortcut method, because we already seen that the property of irrational is that if we do the product of rational and irrational number, which is always equals to irrational number. Okay, this is a property also. So friends, now here we are ending our session. Now we will meet in the next lecture. So thank you very much guys for listening me.